Okay, chapter 7b, number 5. In this one we're trying to prove, actually in this one I took out the circle from the picture because it's not necessary. And what we're trying to prove here is that one of these sorts of things, now if I write this out, it's AB times AB equals AD times AC. And we've done a couple proofs like this now where the goal is to get, I'll do this over on the side, the goal is to eventually get one triangle is similar to another, and then we match up. Right now this is the only way that we have AA similarity to get similar triangles. And then we try to match up either an angle with an angle using corresponding angles of similar triangles are congruent, or a proportion with a side over a side equals another side over another side, because corresponding sides of similar triangles are in proportion. And then maybe you do one other thing afterwards. Okay, and up here is where we're going to try and match up the angles. You might try to match up sides too, but right now the only reason we have are angle base, no sides. So we're going to match up A's. So if we look at our proof here, the first thing we have is a pair of angles. One goes with two. So here's angle 1, here's angle 2. Right? So that's given. Now we need to match up another pair of angles somehow. And there, you know, some people want to look at these two angles, but those actually don't even look congruent. The one over here looks acute. That one look, or this one looks obtuse. This one looks acute. So those aren't congruent. But what you could do is, if you look at the small triangle over here, ACB, this was angle 2, B, and that had a curve on it. We knew that was congruent to angle 1 in the big triangle here. And the big triangle is ABD. And if you notice, these two triangles both have angle A in them. Right? So in a proof, that would be reflexive. So angle A is congruent to angle A is reflexive. Okay, now if you look at the two triangles that I've drawn right here, whoops, I have enough to say that they're similar. So I can say, if I call the first triangle ABC, that would be similar. So ABC goes 2 curves, 1 curve, no curves. So it'd be ADB because of angle similarity. So I have that now. So if I look at what I'm trying to prove up here, right, those are all side lengths. So I'm not going to aim for the angle version. I'm going to aim for the sides. Okay, so let's color code our triangles now that we know that they're similar. So AB here, whoop, AB here is between the two curves that I've marked. So that goes with AD down here. And that's good because there's an AB and there's an AD up here. So those are in blue. And then I've got another AB and an AC. So here's AC, that's red. And down here's another AB. And if you look at it, the red one here goes between the no curves and the two curves. So this one's going to do the same thing right here. So those go together. So when I set up my proportion in the next step, right, I need to set up a proportion using my picture. And then I'm going to cross multiply and hope I get the thing that I'm trying to prove. Well, I know that the thing I'm trying to prove uses only red and blue lines. So I'm going to do this red, the red from the first triangle over the red from the second triangle, equals the blue from the first triangle over the blue from the second triangle. So that's going to be AC over AB. So these are the red ones. In fact, I'll put them in red here. So in red, AC over AB equals, and then in blue, it's the blue AB over the blue AD. And then when we cross multiply, we're going to get AC times AD equals AB times AB, which is AB squared, and this is the same thing that we're trying to prove here. So 5 is because we cross multiplied, and then we're done.